Hey guys. Happy Tuesday. I hope that you guys are staying safe and that if there was any confusion from yesterday, that has been cleared up by now. After kind of the trial run that was yesterday. Um, so today I wanted to continue talking about scatter plots, and so specifically talking about constructing those scatter plots from a set of data. But I wanted to start by doing a little do now, just to kind of refresh us on what we were talking about yesterday. As you can see, I already did part of the notes for the day, just to save a little time, because this is actually my second time around trying to do this. The first time around, it just took way too long just trying to plot all the points while still having you guys watching the video. So I skipped that part. And so I wanted to just jump right into doing the do now. All right. So number one in the do now says the table shows the number of students remaining on an after school bus and the number of minutes since leaving the school. Right. So we have the number of students on top, and so generally I would say that that's probably the x-axis, the x variable, and then I have the y variable on the bottom. Okay. So in part A, it says to write the ordered pairs from the table and plot them in a coordinate plane. Obviously, I don't have a coordinate plane, and it's just going to take too much time. So I'm just going to write out a few of them just so that we can kind of see what they would look like. And then we should know by now, it's March. We've been doing graphing since pretty much the beginning of the year, how to graph those and what that would look like. Okay. So I'm just going to write out a few of the ordered pairs. So 56, 0, 45, 5, 39, 9, and etc. and etc. If I had more room, then I would keep going, but I just don't have enough room. But you kind of get the picture on how we would just go ahead and write out these ordered pairs, right? So then I'm asked to describe the relationship between the two data sets. Okay, and so if we talked about this yesterday, so if we had a question, just please let me know. But we talked about this yesterday where we were describing the relationship. And so if we're looking at the kind of x variable, it looks like the number of students goes down while the number of minutes that since leaving the school goes up. And so we kind of talked about this where if we have one variable that's going down and the other variable that's going up, we called this a negative association. Okay, and so this should be in our notes from yesterday. Okay, so we have that negative association. When one variable goes down, the other goes up. Okay, so in number 2, it says the scatter plot shows the number of bushels filled and the number of apples picked. And so part A asks how many bushels are needed for 350 apples. So if I'm looking, apples is on my x-axis, so I'm going to look. It looks like I'm counting by 50s here, right? It just looks like to save a little space that just shows the hundreds, but it looks like it's about 50s. So I have 300, then I have 350 here. So if I go up on the y-axis through where 350 is at, so I have 350. It's probably going to take about 16 bushels, right? 16 bushels. Right, and so I got that because I looked at the x-axis and I found 350, and then I just went up to where that point was for the bushels filled on the y-axis. So I have 350 and 16 bushels. Okay. So about how many apples can be placed in 8 bushels? So this time I'm going to do the opposite, right? So I'm looking at where 8 bushels is at. So I have 8 here, and I'm just going to go across to see how many apples can fit. And so we said we have about 150 here. We have 200 here. So that's about the middle. So I would probably estimate that about 175 apples. Okay. That's probably what I would say. 175 apples for that. Okay, and so if I describe this relationship now, I'm probably going to describe this. I can visually see this, and so I'm probably going to go ahead and say that there's definitely a positive relationship, right? As the number of apples goes up, the number of bushels is going up. So definitely a positive association. We can probably also say that it is definitely linear, and there's not a lot of data points to go off of, but I guess there's probably also a stronger relationship that goes on here. Right, so those were the three things that we talked about yesterday, was there being this type of association, whether it's positive, negative, or no association, whether it's linear or non-linear, if it looks like it'll make a straight line or not, right? In this case, we have this kind of straight line there, so it definitely is linear, and not, even though there's not a lot of data points, the data is pretty strong because it is pretty close to a straight line. Okay. So for number 3, it says describe a set of real life data that has a strong positive linear relationship. And so I think that my guess would, it could be anything, it could vary. But the example that I'm going to go ahead and use is, we could say the number of hours that you studied for an exam or something like that, and the grade you get, right? And so we would say that probably the number of hours that you studied, in most cases, it is probably going to result in a higher grade. So as the number of hours goes up, the grade that you get goes higher, which means that there's a positive linear relationship between the two. All right, and so in number 4, it says that the scatter plot shows the number of yard sales in your neighborhood each month for a year. So in part A, it asks how many sales are during the month of February. So February being the second month, so I'm going to look for 2, and I see 2 is there's no yard sales in February. So in February, I'll say that there's no yard sales, 0 yard sales. And then I know in June is the 6th month, so I'm going to go over to 6, I'm going to go up, and I'm going to see that's between 15 and 20, so I'd probably say approximately 17 yard sales. Okay. Now, we obviously are not going to go ahead and be accurate as accurate as we would like. So a nice estimate, 17, 18 there is probably, it will be acceptable, right? If this showed up on the quiz on Friday or anything like that, an estimate would be acceptable. An estimate between like 17 and 18 would be acceptable. Okay. So during which month or months are there 0 yard sales? And so if we look across here, we can see, okay, so there's 0 yard sales at the first month, the second month, and then it looks like there may be 1 during November, but then there's 0 again in December. So I would just go ahead in January, February, and December. Okay, so I'm just looking across here at 0 to see which month has 0 yard sales. Okay. So in part C, what type of relationship does the data show? And so if I'm looking at this, there's not really, it's kind of non-linear, right? There's no straight line that it makes, right? It kind of looks like this. So that's definitely non-linear. I would say that there's not really it's probably a weak relationship, a weaker association. And then, not really positive or negative. It kind of goes up and down. So I would say probably more like no association. Right. So the next question is, what type of climate might this neighborhood have? And so the climate, I would say, is probably seasonal, similar to that of what we have here. And so basically what that just means is that we go through all 4 seasons. And so that's kind of clear based on the number of yard sales that we have. So as the months go further and we get into the warmer months like May, June, July, August, even September, we have quite a few yard sales that go on in this community. But then during the colder months, the typical colder months, for us, where it's January, February, and definitely December, even March and November, we don't really see any yard sales going on. So I would say it's probably seasonal. It's not like it's always hot like in Florida or in California or something like that, right? So it's definitely seasonal. And so in part E, I actually want to skip that because that's actually what we're going to go ahead and talk about today. Okay. So again, if you have any questions, please go ahead and feel free to reach out. Pause the video, email, do what you need to do, and then you can always come back later. Okay. So next, I want to go ahead and jump into the notes for the day. Okay. So the notes for today is about constructing a scatter plot. And so it says that Jared's basketball team stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal and the number of baskets made is shown in the table. And so I went ahead and labeled the X and Y, variables. All right, so we have the distance kind of as the X variable and then the number of baskets that were made in the Y. And so we were supposed to use the table to make the scatter plot. I've done so already just to save a little bit of time. And so we're going to go ahead and answer the questions below. Okay, so it says, what type of association do you see in the scatter plot? And so we're going to list any other observations in the space below. So in general, I would probably say if I'm looking at this data, and I'm going to change my colors here, there's probably kind of a negative association. And the reason I say that is because there's kind of this kind of straight line that goes by on all this data here. Right, there's this one kind of random dot over here, but it kind of is like a negative association. As the distance gets higher, the number of baskets gets lower. Right, so we can go ahead and answer this as a negative association. Okay, and then some of the other things that we can maybe talk about observing is that we can say that there seems to be, I would say that there seems to be a gap. Right, there's this huge gap in between these data points here, right? So there's this huge gap here, and I know I erased a data point there, but there seems to be a gap between them. All right, I'm just going to go ahead and abbreviate that, between them, right? And there's also this, we can also talk about the random point that's kind of away from everybody. So there's also a random point that doesn't fit. Right, that's nowhere near what the rest of the data points. Right, so we have this negative association, and there seems to be a gap between the data points, and there's also this one kind of random point that doesn't fit. Sorry, and I didn't write that, but doesn't fit. Right? So, this is important here. So like we talked about in the do now, that last question in the do now says, identify any outliers, gaps, or clusters and explain why they may exist. Right? So when we have this gap, right, this is important, right? It's not something that we're gonna, formally talk about today, but that's why I'm going ahead and mentioning it here in the notes, because there will be some times where there's this gap between data, and so we want to go ahead and point that out when we're describing what's happening in these graphs. Okay. So next we're going to go ahead and use the scatter plot to label each statement as true or false. And so for part A, it says, as the distance from the goal increases, the number of baskets made decreases. Right, and so I would say that that's probably true. As the distance kind of increases here on the x-axis, the y-axis kind of goes down. So I would say that that's probably a true statement. Okay. Then we have, as the distance from the goal decreases, the number of baskets made increases. And so that's kind of just the inverse or the opposite of that last statement. So that also I would say is true. Okay. And as the distance from the goal decreases, the number of baskets made decreases. And so I'm not sure if that is correct. So I would say that this is a false statement. Okay. So we have these outliers and clustering, and so these are again the important parts of what we're talking about today. So we have these things called outliers, and we have these things called clusters, and then we have these gaps, right? And so those are the three things that we're going to go ahead and focus on when we're describing relationships, right? And so we have an outlier that's it. This is a point that doesn't fit the overall pattern or trend of a scatter plot, otherwise known as an outlier, right? And so who is the outlier in the scatter plot above? And so we're going to go ahead and explain. And so if we look at that, between 12, we're counting by twos kind of, just to save a little space, I skipped some. So we're counting by twos on the x-axis. So we'll say that this is 14 comma, this was 14 comma 4, right? And so 14 comma 4 was Jared, right? So 14 comma 4 or Jared was our outlier, right? So we can go ahead and explain this by saying the number of baskets made was much lower than his team, right? So Jared, who was at a distance of 14 feet and only made 4 baskets, is our outlier for our data. Okay, so we also have these things called clusters, and so clustering occurs in a scatter plot when there is a distinct or separate group of points, right? When there are distinct or separate groups of points. Okay, and so why do you think clustering occurred in the scatter plot above? And so if we look, I know I kind of covered it up by the line that I made before, but we have kind of this cluster here, and then we kind of had a cluster up here, right? And so we're going to go ahead and describe why we might think that there's clustering above. And so what I would say is that it seems that a group stood closer and a group stood further away, right? And so that might be why there's this clustering of, these players, right? So we have this group up here that they had their kind of shorter distance all around kind of the same place, and they made, kind of the same amount of baskets in a way. And then we have this group over here that stood pretty much around the same, between 25 and 28 feet, and then made the same, pretty much kind of the same number of baskets as well. So we have these clusters, which are just these groups of points, and then we have these outliers, which is just a point or points that doesn't fit the overall pattern or trend. Okay, and so these three things, gaps, clusters, and outliers, are the three most important things that we're going to take away from today when we're describing relationships. Okay, so I'm just going to move on to the second page here. Okay, I'm moving down to the second page. So next, we have some examples. So it says the population of 10 cities and the number of elementary schools it has is shown in the table. Make a scatter plot for the data, right? So we're going to kind of have this data here, or we have, okay, so in thousands, so we'll say population in thousands, so we'll say 76. 76 is kind of here, and so that goes up to 19 there, right? So basically our data is going to kind of be all over the place. We're going to have one that's kind of like here, we're going to have one that's kind of like there, and one that's maybe like right here, and then one that's like kind of there, kind of just all over the place, right? And so I'm going to go ahead and just put these data points in here. They are not accurate, but just to save some time on the video, I just want to go ahead and put those kind of data plots in based on kind of where I see them on my answer key. Okay, and so we can go ahead and answer the questions below. So the first question is, describe any association between the variables and what conclusions can we make? So we can go ahead and talk about something that we talked about yesterday, and so we can definitely say that there's probably a positive association, right? There's definitely a positive association, you know. So we can say that as the number of schools increases, the population increases, right? Or vice versa. As the population increases, the number of schools will also increase, right? And so if we look at this, we can kind of look at this asking ourselves if there are any outliers in our data. And so if we kind of look at this, we kind of have this data point of 20,000, right? And so that's kind of Glen Falls here. So 20,000. So we have this, it's supposed to be this point up here, right? And so we'll say that this is kind of an outlier there, right? Because the rest of the data is down here, right? Kind of on this straight line there. So we kind of have this outlier. And so we say that this is going to be our outlier because, so we'll say that Glen Falls at 20,000 because it's much higher than the rest of the data. Right, so these outliers are, you know, kind of just different from the rest of the pattern, right? So we would say that the outlier is Glen Falls, which is 20,000. Okay, and I know that this is not plotted correctly, but I was just trying to save time, so I plotted that a little bit differently than it's supposed to be. So are there any clusters? And so I wouldn't say that there's really any clusters. There's no distinct kind of groups. Everything kind of follows a straight line. So I would say no. No. There are no groups. Right? And so when we were looking at the example on the front, we had a bunch of data points that were all kind of grouped together like this, and then a bunch that were grouped together like that, you know, so that's what we mean by clusters. We're not talking about data points that are just really, really close together on a line. We're talking more about just groups that are kind of a bunch of different data points that are together, you know, at different points on the graph. Okay. So again, any questions, please pause the video, reach out, and then I will get back to you as soon as I can, right? So on Tuesday, lastly, Charlie asked 9 different students how much money they had in their lunch account, as well as how many homework assignments they had that evening. And so we're going to use the data collected to kind of make a scatter plot there. So again, I'm going to just go ahead and save us a little bit of time by kind of seeing it on mine and seeing where those data points are going to be. So we have that one, we have this one down here, we have this one here, this one, and this one. All right, so that's kind of our scatter plot there, right? So we're going to go ahead and describe the association. So I would say that there's probably no association. No association, right? There's no kind of positive or negative straight line. It's kind of like just kind of all over the place. So I would say no association. So what we can conclude is that the number of homework assignments does not affect the money in the lunch account. right? So there's not really a correlation between them. There's not really a, one affecting the other. The number of homework assignments or the amount of money that you have does not affect the homework assignments or vice versa, right? So we're looking for any outliers in the data, and so with the data kind of being all over the place and there's not really an association, we can kind of say that there's no outliers, right? Because there's no pattern. No pattern. Right? And so when we're looking for outliers, we're looking for those patterns. So basically, if there's no association, then there's probably also not going to be any outliers. Right? And the same for clustering, right? We were looking for those clusters we were looking for up at the top. We were looking for those groups of a bunch of data points that are all kind of grouped together, and there's no really groups in this. So again, if there's probably no association, there's also not going to be really any clustering, right? So we'll say no. There is no pattern. Okay. All right. So this is the notes for today. We're just talking about clusters and outliers and gaps, right? We didn't really talk too much after the first page, but that's also very important as we go through this. So again, if there's any questions, please let me know. Me or Miss Blackwood, we're both on Google Classroom. So if there's anything, reach out. Also, make sure to hit like and subscribe before you leave. All right. Thanks, guys.